A common type of variation in our calculations is to calculate a percentage purity. In these types of calculations, you'll be asked to usually find the mass of a pure sample because you've already been given a mass of the impure sample and to determine how pure it is, the percentage purity. With these types of questions, the biggest thing you have to be careful of is that you can't find the mole of an impure substance. So if it says it's a mixture or it's got something else in it, then it's impure and you can't find the mole. So always think danger, danger, danger. I can't find the mole of an impure substance. But you will be given enough information to find the mole of something else. So from there you can use your stoichiometry to find the mass of the pure substance, and then you apply your percentage purity. Now let's look at an example. It says here, and this one's being very obvious, that we've got 0.865 grams of impure sodium sulfite. So you can't find a mole because it's impure. But we've been told that this reacts with 0.0995 potassium dichromate and needed 17.1 mil of this substance to convert all the sulfites to sulfates. So that is where we're going to find our known. So our known is the dichromate. And from there, we can calculate the amount of pure sodium sulfate. So let's have a look. So the number of moles of potassium dichromate will equal the number of moles of dichromate, which is equal to CV. So our concentration is 0.0995. Our volume was 17 mil, which we have to convert to litres. And this will come out to 1.70145 by 10 to the negative 3 moles. Now we need to find the number of moles of our unknown, which is the sulfites. So the number of moles of the sulfites is equal to unknown over known times the number of moles of the dichromate. So in this case, it'll be 3 over 1 times 1.70145 by 10 to the negative 3, and this comes out to 5.10435 by 10 to the negative 3 moles. So the number of moles of sodium sulfite will be the same. And please make the statement so that your marker is your friend. So the mass of the sodium sulfite will equal the number of moles times formula mass, which is 5.10435 times 10 to the negative 3 times 126.05, and this is 0.6434 grams. And this is how much pure sodium sulfite there is. Now that we've got our mass of pure sodium sulfite, we can apply our percentage calculation. So we go the percentage purity will equal the mass of the pure over the mass of the impure sample times 100, which in this case is 0.6434 divided by 0.865 times 100, and this comes out to 74.4%. And we've got 1, 2, 3 significant figures, so 1, 2, 3 significant figures. So you can try some yourself by going to the OneNote, Rates and Equilibrium Calculations, Calculations 1 and Question 11, and also STAWA 12, Set 31 has some sample problems.